And welcome back to our system skill and low-level programming lecture. Today we'll continue on from lecture 1. And before we go into Linux environment and how to actually navigate to Linux, we'll do a quick recap of Tuesday, right? So we talk about operating systems conceptually. It is super high level, right? In a super high level, the OS, basically, as the name suggests, is a system that used to operate the hardware. You have the hardware that you buy. You go to a computer store, right? And you bought a laptop. You buy a computer. What you got with that is Windows or Mac OS installed, right, on the machine. Those software are called operating systems, and the main task that operating system is doing is, for whatever application you want to run or whatever things you want to do in the hardware, operating system act as the the intermediary for you. Basically, it talks to the hardware for you, and it manage a lot of things that would make the life easier for the user, right? What are those things that they're managing? We'll learn in the third module. We'll learn some of those in the third module. We'll learn more in the PCSA class, right? So hopefully you are looking forward to that. Um, oh yeah. So some of you might have the timeout thing when you try to access the server. That's a great question. So the question is, so what's the timeout for incorrect password when you try to access the server, right? So let me ask you this. Whenever you see a timeout, what does it mean? What does it suggest? So what does the word timeout suggest? It takes too long, right? Basically, you're waiting for something and you have no guarantee that someone will respond to you, right? So let's say I have an action that I perform and I'm expecting someone to reply, but I have no idea whether someone would actually reply or not. One thing, so what shall I do? How can I tell to myself to stop waiting? What should I do? So what would be your strategy? Uh, well, let's just say I perform some action, I'm waiting for some reply, and I have no guarantee that they will reply. So what should I do? Well, should I wait? Should I wait for some time until someone replies? Or yeah, another thing I can do is assume that no one will reply, right? But what would be your desirable system? What are you supposed to do there? You would like to get a reply, but you don't know how long you have to wait for. So what should I do? How about this? Let me rephrase the question. And yeah, that's a great answer. So, but let me rephrase the question just to make it clear. All right. How many of you would like to organize a trip somewhere to go for a vacation, or just a 1 day trip to somewhere just to have fun or go eat or something? You tell your friend, hey, I'm gonna be there in front of the campus at 10 o'clock in the morning so that we can go on time and arrive at the restaurant. How many of you have those friends that sometimes just show up and sometimes decide not to show up? How many of you have friends like that? What should you do then in that scenario? You're waiting at 10 o'clock. What should you do? It's you. That person's you. Okay. Thanks for admitting that to all your friends here in the chat. So you can call the person, right? So that's one thing I can do in this computer system. I can send another request like, hey, are you there? If you dare, answer me. So definitely legit answer. You can call the person. But if you call and there's no reply, so what should you do next? And sure. Well, it's actually one thing you can do is basically mark this particular system that you're trying to contact that, hey, that system doesn't reply back to me. There's probably something wrong, right? And you can send a message in case that person replied. That's a totally legit thing that happened in system as well, right? These strategy, this strategy can be applied in a real system, in the real computer system. You can send a message saying, hey, if you suddenly come back, here's where I'll be. That's how you can catch up to me. Another thing is your friends already answered that. John, thank you so much. Set a timer. I can set my own timer saying, hey, that's another great answer too. But let's go with a set a timer first. I can say, hey, I'm gonna wait until 10 past 10 o'clock, 10:10. If it's longer than that, you go to the restaurant, we don't care about you. All right. That is what it meant to time out. You're waiting and it doesn't, you got nothing. So time out basically mean someone set a threshold for how long that I have to wait until the system receive the reply. If I don't have the reply, I'm gonna ignore it and I will have a way to handle this timeout. One common way to handle that, stop what you're doing, saying, hey, it's timeout, fail, operation fail, whatever, right? That's one answer which is interesting. Go to their home and ask for their parent. Why are you asking for the parents, not the person you're trying to contact? That's weird. Um, okay, I'm not gonna comment about that, but I guess you can talk to the parents, right? Then that definitely would work. The parent might, well, sometimes, most of the time, they can contact the friend for you, right? But that's a possible strategy as well, right? Then basically you try to go there. The problem with computers, can computer walk? I mean, can a component walk? So I can send a message, right? I can send a message. And the now that I think about it, right? Asking the parents is actually something the OS do as well. One thing you can do is that there's a hierarchy of processes, right? So you can ask the parent process what's going on with that thread. Is it has it died or something? I didn't get a reply. So that's actually a legit solution in the system, right? But anyway, great. These are awesome answer to that question. Say, what does it mean when you request timeout, right? So what it means is I have some threshold. Yeah. In the computer. So we do call the so let's say you have a program that launch another program, right? You call the process that you launch a child process. And when it's finished running, well, you can kill the process. Um, not sure if you want to go to the yeah, sometimes we call well it calls sick kill. Actually, we kill the thread so that it stop running. That's what happened when you click the end task. You send sick kill to that process. All right. Um, maybe not a great choice for the wording, but we use it in textbook, so I'm gonna stick with that word. All right. Okay, everyone. And I do agree when you put it that way, it does sound weird. All right. In any case. Awkward. So yeah, when you have a request timeout, basically you send a request trying to put in the password. The server doesn't respond. So you got nothing from a server. At some point, you stop trying to listen to it. Say, hey, I'm gonna move on. You can then maybe change the command. Maybe you put the IP wrong. You put the machine name wrong. There's some typo in the command or things like that, right? It's basically a threshold to figure out how long you should wait. Most of the time, these timeouts are good if you know how it works. In some cases, it can be really bad as well, right? And I'll give you one example. So, and this has happened to me before, and I feel like it's a really, really poorly designed decision by, I think, a group of Thai professors somewhere that designed this system. So There's a central system where everyone in the university, like me or Ajahn Kanat or Ajahn Sansern, when we want to send in research proposal, right? So that we can get research grant, so that we can actually do some research that would be hopefully moving the community forward, right? But in Thailand, there's this website that handle all the submission. It's a submission system where you can send in a proposal. Fun thing when there's a lot of users trying to submit the proposal during the deadline. Anyone can guess what would happen if I have, say, 10,000 people trying to submit a file. Yeah, like let's say you have Sky Plus and everyone wants to do something with that, right? It overload. It's congestion is a great word. Congestion is a great word. Overload is also a great word. Crash is also a great word. In most cases, it actually will not like totally crash, but there'll be so much data queuing up trying to be processed. So one thing that can happen, it takes a lot of time to process your request, right? Some researcher in Thailand make a really, really poorly designed decision, put a timer that are really short, to handle the request. So anyone here want to guess what would happen if I have, say, only 1,000 different users connecting to the system and try to submit a proposal? No one gets it. Yes, because the request, I mean, it might take 1 or 2 or 3 more seconds longer, but because you set the timer at 2 seconds, it failed. It all failed. It's more like all the research proposal never gets submitted. So do you know what I do? Do you know what I have to do to go around that stupid design decision? Now, actually, I call it stupid, and I think I should call it that way, right? But I ended up having to wake up at 1 a.m. in the morning so that I can submit it. And everyone in the community, like in the academic community in Thailand, kind of know that weird design decision. And we know that if you want to submit on the day of the deadline, you probably will not be able to submit. So wake up at 1 o'clock, submit at the time, and do things like that. I hope it gets fixed at some point in time. Last time, I don't even want to risk, right? It was so bad the last time I ran into this problem. But yeah, these are some of the really, really I mean, this particular example doesn't apply to you. It's something I ran into, and I think it's a really, really, really stupid design decision. All right. So I'm not gonna name names or anything. It just has something that happened in the Thai computer scientist community. And how does other countries handle that? That's a great question. That's an awesome question. Most of the time, right? If you have this particular problem, one thing that you can do, and if you don't mind, I'm gonna go off topic a little bit, right? One thing you can do is you can scientifically test your system so that you know, okay, if I have 3,000 different users logging in at this point and everyone is trying to submit file, can I handle that? If I can, how long does it take? It's not hard to generate that traffic. It's called synthetic traffic, which basically make up the traffic so that it stress the system, right? And you can basically do this stress test, right? From 1,000 users, 2,000 users, 3,000 users, 10,000 users, 20,000 users, and more, right? And that would test your backend. That would test your server. That would test your infrastructure, right? Another thing that you have to do is on the backend side, check the utilization. Are you using all the component to its fullest, right? If you are using 5% of the CPU and you somehow have this slow down, maybe someone's trying to write to the file, to the hard drive, and it's slow because the design over there is not scalable. So you can redesign them. The point of doing computer systems, basically the point of this class, is to understand the basic concepts on if you need to fix those things. How would you redesign the infrastructure so that it scale, right? I mean, imagine if Facebook can only handle 10,000 people. Would anyone use Facebook? No, right? Obviously. And right now, Facebook can handle so many concurrent users logging in and stream to all those news and ads and so much more apps and more apps on Facebook, right? It means that they scale their system so that it's super capable of sending you this data. So it's doable. It's doable. So if I were to answer that original question on, then how do we figure this out? Stress test the system so you know the limit. If you know, hey, that's good enough. I mean, that's not going to be more than 10,000 users logging in at the same time. We don't even have that many researchers in Thailand or something like that, right? So yeah, that system is good enough. Then I can just go with a basic, like one really old server and some cheap setup, and that can handle all the workload, right? Um, so these are some of the things you can do if you know computer system and you pay attention to, I guess, the actual use case that's likely to happen, right? If you read system paper and you have to manage this, you know that these are things that would happen. It's like it's such a basic thing that you need to know, right? So that's why I call those things a really poorly designed system, right? And I hope you guys, future generational programmers, especially the people who took my class, hopefully you guys did some much better job than our previous generation of programmer. And I say that I really hope so. As a joke, I would like to say we are in a really low point in computer system community in time. Don't be sorry, guys. Come on. This is your first class. You have so much future for you. And and to be honest, you have a really awesome community of that lecturer at MUIC. If you haven't realized, actually, it's like quite a lot of experts at MUIC CS department comparing to many other university in Thailand, right? Um, that can harden you through assignments, lectures, more assignments, and exam, so that you can work and elevate the community. And I'm looking forward to those days, right? Yeah, so let's elevate the community together so we have a better system, right? So that things like, for example, anyone remember when BitCup has to close down for a bit because they cannot handle the load? I think it happened last year, right? Anyone remember that? The company BitCup that do the exchange for the cryptocurrency? Yeah, they stopped registration for new user because they know, hey, I cannot, my infrastructure cannot handle that many users, right? I mean, I seriously hope that we have better system community because right now I can probably count on my two hands the number of system experts in the country that are in the university system to train new generation of students and engineer and computer scientists and programmer, right? Yeah, it was a Dogecoin hype. Yeah. So that those things doesn't happen as often, right? So we have more not even back-end people, like back-end in web development, where you would basically kind of design some of the system architecture, but people who can actually look at the infrastructure, right? I typically call this not even back-end, I would call it like back of the factory kind of thing, right? But these people are so crucial to scaling the traffic, scaling the infrastructure and make sure it works when you have more customer. All right. Anyway, so I'm gonna come back to the recap of Tuesday. Sorry, guys. I again, you know me now by now. Just two lectures and how much I like going on a side topic. And I do hope you find those informative and entertaining, right? Yeah. So we hope you guys can help like elevate the system community. Anyway, so OS conceptually is basically it's a middle person between the hardware and the user, and it's there to help you. And we talk about the terminal, right, where it emulates the server's video terminal on your display architecture. So this is basically something that would illustrate the terminal. Your own keyboard input at the bottom would send the input device to the server. The server would process that, send the display to your machine. Right? And you can also do this on your computer. We also talk about program versus processes. Program is a program as you know it. Right? Basically, you buy a game, that's a program. When you run that game, it becomes a process. When you run that game, it becomes a process. Shell is a program that takes your command, send to the OS. It's that arrow, basically, you send a command, the OS takes the command and run it. And you use basically the combination of shell and terminal. So what I asked you to do on Tuesday, which is logging into the server, you actually full-blown go through this process. On your own laptop, you have the terminal program, right? On Windows, it's Windows Subsystem for Linux or PuTTY, depending on which terminal application that you're using. That terminal application sends, yes, it's recording. It should be, right? Let me double check. Yes, it is recording. The terminal program basically send the request over to Shell. Shell send that command to the host OS, and the host OS run the command. We'll do more of this today in the in-class exercise number 2. Now let's move on to what we are supposed to talk about today, more on Linux. We only start 25 minutes later than I anticipated on these slides. But the first thing first, we have to talk about where are your files and how are they organized. So how many people got used to the Windows Explorer and like the Mac OS way to handle file and how you browse through that by clicking the folder and clicking the directory? We all got used to that, right? Anyone not used to that? Anyone? Okay, I would assume this is basically a default, right? In Linux, same things here. Everything, program, the data needed for the program are stored in a file. And they are organized in a directory. Inside Linux, this is something you're going to see a lot. Basically, when you want to list out the file, because when you log in, right? It's okay. I mean, if you are still not sure about different shortcuts and how you manage to go through the directory structure, that's fine. Because I mean, at some point you would learn, right? At some point you might discover fancy, cool new thing. And feel free to check with me on okay, what else can I do? But today we're gonna learn some shortcuts. All right. So let me break this down. This is one of the example of what you see when you want to list what are the files that are in this directory. Because you don't have the graphic interface, you basically type things and you see these text-based stuff, right? So if I have a text-based interface and I want to list out the file, what would happen is when I send the command to list out the file, it basically print the file name, right? And the information about the file out to you. We will break down this information one by one, but you can probably guess what is this? What's this part? September 17th, 625? Yeah, so I've modified time, right? This is the file name, right? This is the group ownership. We'll talk about that in a bit. Owner. Basically, this is also the owner of the file, right? So basically that's it. You know who is the owner of the file. You know who is like what group can Basically, what group own these files. And these are the permission. So can someone tell me what's the benefit of having a permission on a file? Yeah, it's restrict unauthorized accesses, right? Can someone guess what's R for the permission? Read, yes. How about W? And how about X? Execute, yeah, awesome. So basically it's read, write, and can I run it? Can I run it? Let's say it's a program. Can I run it? How about D? Directory, yes. Basically, D, if there's a letter in front, for example, here, apt is a directory. It's not a file. The rest are file, right? File and directory are organized in a tree-like structure. So what's a tree looks like? What's the beginning of the tree? Not sure how to rephrase it, but root, thank you. Yes. As I said, it's like I'm not sure how to phrase that question, but the tree, if you look at the tree, it starts from the root, right? It starts from the root and it grows up and it branches out, right? So basically, your computer, if you have Windows, what's the root? What's the root of your file structure? In Windows, there's no root directory in Windows. So for those of you who use Windows, so it's basically that my computer, right? Even before you go to C drive, that's where you can access every single file on your computer. How about the Mac OS? The slash, right? Slash is actually not tilde. Tilde is a home directory. That's not the root. If you go to tilde, you can go up. You can actually keep going up until you reach the point where you can't go up anymore. That's like a slash. That's the root directory, right? And the extension like .text, .pdf, it doesn't mean anything. And I say that with a quotation actually. So if you see some file with a .text, what does it suggest? Sorry about my cat. Can you hear that? Yeah, .text is a type of file that say in there it should be just tons of text. Can your friend comes in and throw you and change the file type on your text file? Yes, they can do that. So that's why I said it doesn't mean anything. It's just a suggestion that if you see .text and you in Windows you double click on that, what's likely to happen? It opens Notepad. Awesome, that's a great answer. Basically, some text editor would be launched, right? It would open the file using the program tied to the extension. Anything that after the dot, we call this extension. And .pdf, what would it open? PDF viewer, right? Basically, it suggests that, hey, the file type is likely to be the PDF file, so I can use the PDF viewer to look at the document, right? So let's say if I change a .text file to JPEG, what would happen? It many things can happen, right? Depending on what program are being used to open the image file. And it would detect, hey, I don't know how I'm gonna show this picture because it's a bunch of text, right? So it might be some broken JPEG if it's a really, really basic like a JPEG viewer. But most of the time we say, hey, the image is corrupt because I don't know how to show this image. It's because it's a bunch of text, right? So as I said, it's just a suggestion on what are the program or application that can be used to process the file, right? Space in the file name is okay. But if you want to say, hey, anyone, like for those of you who use Windows, right, you have this folder called My Document, right? And you notice there's a space in the middle, right? This is the space. So let me kind of ask a rhetorical question, right? How can I tell? So let's say I have a command that says open my document, right? Something like open. And let's say it's a magic command that open the file, right? Open my document. How can I tell that is this one file called my document? Or are these two separate files? The first file is called my, the second file is called document. Can I tell the difference if I don't do anything? No. Awesome, right? So basically, the answer no is correct. I can't differentiate between the two files, one called my and one called document, or there's one single file with the word my document. So what most of the, I would say all the solution right now is I'm going to put the escape character. It is a hidden character that say, if I see this character, treat that next letter as a part of this text. So my document in reality is basically my, and then the escape character followed by a space, and then document. And when you open this, it actually now becomes one file called my document. This is basically how you can link special symbol. Basically, the escape character is used for special symbol for your letter-based text. Anything that starts with a dot in Linux, anything start with a dot is a hidden file. Remember the .ssh that we created from Tuesday? So that's a legit directory name, right? The dot in the beginning just say, okay, if someone tried to list this in the folder, in the directory, this name will not show up. It's a hidden directory, right? So what's the benefit of a hidden directory? Can I try to use it to organize my directory so that it's not to mess up with so many hidden directory that are specific to certain features in my system, like SSH, right? I'm not going to use that file a lot. I just need to put the config right there so that when I use SSH, it's read the config and it do what am I putting in there. But most of the time, I don't care about what's in there. So I can put the dot in front to make it hidden, right? So you can do that. Now, we have the directory structure. So we have to talk about this thing called a path. Well, what does path mean? Is the location of a file. Awesome, that's the correct answer. And there's two formats for the path. You can put in the absolute path. Absolute path basically means that I put in the full address for the location of the file. So because I said the root directory begins at the slash, right? So /var/log is the full location from the root to the log folder. Relative path is from where I am, how do I go to another directory? So think of it this way. Absolute path is like in the real world, I give you my address for where I am. Relative path, I give you the direction. Go there, turn left, turn right, go straight for 10 kilometers and you arrive, right? So there are two ways you can specify the path. In most cases, when you are using the terminal, one thing I can tell you, most of the time you're going to use the relative path because it's much easier to browse through your directory. It's like when you click back and forward and back and double click. The absolute part is actually pretty useful when you want to script and make sure you write a certain script to run certain things. That's also a special path. Tilde refer to your home directory, right? This is where you start when you log into the server. Now, has anyone noticed that everyone, when you log in the server, you start somewhere? There's like a directory where you are in at that point, right when you log in. Right when you log in. So let's say in the server that you guys are using right now, the syscue server, how many users are using the server right now? How many users are there right now? It's quite a lot, right? That's quite a lot. So what would happen if when I log in and when you log in, when your friends log in, we start at the same place? What would happen? Well, it wouldn't crash, but it would be a mess, right? I mean, imagine how messed up that directory would be. It's not going to have a traffic jam or anything. Everyone can access that directory, but let's say I work on that directory. You also work on that directory. Your friends also work on that directory, and everyone try to create their own subdirectory and everything. It's going to be a mess, right? It's going to be a mess. And the way Linux and Unix-based operating systems try to make sure those are organized in a nice way is when I create a user account for you, right? It basically creates a directory called /home/username. So in my case, my username is Rashada, right? So there'll be a directory over there, home Rashada, so that when I log in, I start there. In your case, your home directory will be /home/u6 blah 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 blah, your student ID. So that's your home directory. This allows you to basically everyone now when you log in, you have your own secret location that is on the system. You can use whatever there in there. You have the permission to modify whatever is in there. Um. Oh yeah. So it's a forward slash. My bad. Backslash is like a Windows format. Another special part, right, is the dot. What's this? Anyone use Linux or Unix before? Can you tell me what dot is for? Yeah, right where you are, right? Basically, it's current directory. Dot dot, you go up one level. That's when you go, okay, I'm gonna go up one directory level. Slash, // again. Backward slash is used in a Windows system like DOS based system. A forward slash is used in Unix. Slash refer to the root directory or the topmost directory. So now with the directory structure, we start to go through some basic commands that we need for our in-class exercise. All right. So here are some basic commands. Before we begin with the basic command, once you log in, right, you can type in the command this way. Command name followed by the argument used for the command, the options, the file name or whatever, right? Put in the command name first, followed by the arguments for that command. The first command I'm going to teach you is ls. It stands for list. As the name suggests, it lists file and directory in the current directory. So you can do options with ls command like ls-l. ls-l would list the file with details. When did I modify the file? What's the permission and everything? If you do ls alone, you just see the file name without those permission, without those last modified time, without the owner of the file and all those things. ls-l tilde would list files and directory in your home directory. Because you put in the path, now you put in the path, this special path tells you, okay, it's a home directory. So it's going to list every file in your home directory. CD followed by the target. CD stands for change directory. As the name suggests, it changed to the target. CD dot dot go up one level. CD slash go to root. CD tilde go to home. CD dot slash hello will go to the folder called hello in this directory. All right. By the way, I'm going to go through this really, really quickly because these are basically something that you can come back, and we have the slides posted on Canvas as well. So I don't feel there's a need to kind of expand more than the current explanation. It's more beneficial that you play around with our in-class 2 exercise and play around with Linux yourself, right? So I'm going to go through this relatively quickly. If you have questions, let me know. Type in on the chat. What else? mkdir, make a new directory. rmdir, remove a directory. If you use rmdir, it would give you error if the directory are not empty. It would give you error if it's not empty. So you need to remove file in there first. mv move the file from source to destination. You can also rename a file using the move command by saying move file name, new name. cp copy, used to copy the file. You can add -r. You can add -r as a recursive copy. Did we cover recursion in Python class? So what does recursion do? What does it mean to like recurse, like recursive? What does it really mean? Yeah, it's like a function that calls itself, right? So in this case, cp-r means I'm going to copy everything from this directory and everything in this subdirectory and all the file in there. So you move the entire thing. It's useful when you want to copy the entire directory from one place to another. rm, remove. Remove, no destination needed. No destination needed. If you're wondering about that noise, it's the culprit, my cat. Yeah, she like to jump on my lap. Why do we need that R for CD? Where do we need that? So let's say you want to copy a directory and the directory is not empty. Just do -r. It would copy all the file from one place to another. If you want to copy just one file, or you want to copy just one file, you don't need -r. How many cats do I have? I have 3 cats in the house. I should have, that's like 2 stray cats in front of my house that I kind of ended up feeding them. So yeah, 3 with question mark. Like 3 cats in the house. This is the third one. Yeah. So cd-r source destination. How you use -r is you put the -r in the middle between the cd command and the source destination. So the option, basically the option like -r, -l, or those things would be typically right after the command, before the file name. Typically, there's a command to get to the manual. We'll go to that soon. Basically, it is a manual for each command. It basically tells you how to use the command with some example. Great question. When you remove a file, it doesn't go to the trash. It's permanently removed. So be careful. Be careful with your remove command. All right? Be really careful with your remove command. I happen to, I mean, when I was doing a PhD, right, I have a lab mate that by accident typed rm-rf. F, R means recursive. F means force. If it gives you warning, I'm going to do it anyway. On the directory that of the program he was building for a while for his research. I'm not gonna tell you what are the swear words that came out after that enter sound happened. He was able to recover those because we have backup, like we have like daily backup for our workstation, but it's not beautiful. Basically, he lose like 1 day of work, right? There's no undo in terminal. If you go and commit that command, it's gone, right? So be careful with your remove command. Be careful with your remove command. But when we learn git, we will learn how we can archive things effectively. So you can't just randomly tell me, hey, I'm sorry, Ajahn, I accidentally to do rm-r on my lab. So that's why I'm late. Nope. We will learn Git. Is there no Git at a time? At that time, when my friends were working on his code, he hasn't commit and saved that version yet for that day. It's like it's lose time, right? Whatever you're trying with, like losing 1 day worth of work is painful. Especially when it's hard. But yeah, he was able to recover that with the combination of archive and Git. Touch basically create an empty file with the name file name. So now we go cover the basic command. Let's say we want to copy every file in the directory to somewhere else. You can use the concept of wildcard. You can use star to refer to everything. For example, I can do cp star /temp. What would this do? Anyone want to guess what would this do? I say star refer to everything. It basically copy, cp is copy, not move. Copy everything in the current directory to the temp directory. You can use slash between each directory level, like /temp slash, I don't know, 1. Basically, it's a directory called 1 inside temp. These are examples. /foo star refer to all file and directory under /foo. And there's many versions of wildcard. We actually use star the most often, but there's also other things like question mark represent one single character. Question mark represent one single character. For example, I can do A, B, C, question mark. Basically A, B, C followed by one more character. A, B, C, D, A, B, C, E, A, B, C, F. Those would match. Bracket would represent a range of characters. So ls-l a star means that I'm going to list every file that starts with an A and has at least one more letter because I have question mark at the end. MVU in the bracket 6 question mark means that I'm going to move anything with the that start with the letter U followed by the number 6 followed by at least one more character. This would move temp example. Oh yeah, sure. Wait, which one? CP star and /temp, right? You mean this example? All right. Two cats, don't fight, please. Don't fight. Is this example I want to expand? You want me to expand? Oh yeah. So let's do one by one. So we have one single store. That means that it match everything, right? Basically, it's a command that say I'm gonna copy something, and that something is anything in this directory. Yes, you are exactly correct. So it will copy everything else in that directory, as long as it's inside the current directory, but not part of temp. But if you want file in the subdirectory of that, you need to add -r. If you don't add the -r, it will be just that level, but not the inside of the directory. So that's what the -r is for. And then here, sorry, one thing, I forgot to put in the destination. My bad. So I need to do move U and follow by the destination, right? In this case, it's a file that starts with letter U. It's a range between 6 and 6. So it's U6 followed by at least one more letter. Why at least one more letter? I have question mark. Question mark means that it's going to match one character. So it's going to be U64. Star mean anything, including nothing. So it can be U64, U645, U64567H, U648. Those would all match. All right. Is it more clear now? Yeah, so you can use this flexibility of the wildcard with the command to do many interesting different version of the same command, to manipulate the file structure, to manipulate even things like the content of your file, as we will learn more commands soon, right? So these are really useful tricks to make it, as I said, these are commands that allow you to be lazy. The more you know, you can then finish many things in 1 or 2 lines of the command rather than 1,000 lines, right? You basically save a lot of typing. What are the other commands? Manual is a manual for the command. Basically, you can say man ls. It will open up VI, a text, but it's a text reader that you can browse through the manual for the ls command. It will tell you how to use the ls command, blah, 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 with all the options that you can use. Cat, not a cute, furry, cuddly thing. Cat mean concatenate. Concatenate mean I'm gonna combine the content of the file together. You can also do something like this. Cat file. Basically, it would print the content of the file. Find is used to find, not file. My bad with the typo. Find a file, right? It has different options that you can use to find just to that directory, or including the subdirectory, and many different versions. You can use it find with combination of wildcard. PWD, not password. Print working directory. Basically print the path of where you are. If you basically go through the directory structure and you got lost, you don't know what's the path I am in right now, you type in PWD. Can you add different type of file together? Yes, with Wirecard. Wirecard allow you to basically add multiple type of file together. Basically, it's a combination of different Wirecard bundle together. Because different type of file are just basically .text, .pdf, right? Grep. Grep is a command to search for specific word in the file. We'll go through the grep example in the next lecture. We are not going to use grep in this lecture and in class exercise, but it's a really powerful command. I use this command a lot when I develop my own code. It's kind of like I'm going to search for, let's say you want to find what file contain this function call. What file contain this function call? I can do grep followed by the function call and the one of the directory, and search every single file in the directory for that line that contain the function name that I search. So I use this a lot when I develop my own code, when I program. You can use the redirection. Redirection basically means that I'm going to redirect the output of the command instead of on your monitor. Basically, when you run a command, most of the time it prints on your monitor. Redirection would print that thing instead of on the monitor. It would put that in the file that you specify. Over here, cat a.text, b.text, c.text would combine the content of a, b, and c.text and write a new file called outputtxt. It creates a new file called outputtxt. You can also append to the existing file. Again, sorry about typo. You can also use this less than sign. So in this case, it's not forward to the output file, but you redirect a file as an input to the command. In this case, for example, ls with the less than sign, fileless.txt means that I'm gonna use this fileless and run ls on all of them. So you can have a text input that you type in before you run the command and redirect the input into the command. Another handy trick that we use all the time is called pipe. What does pipe do? In a real world, not in a computer. What if I have a pipe, what does it do? Just transfer water, right? What about, like, just say in a game Mario, what does pipe do? Yeah, it's kind of like a path. You go in and it go out somewhere else, right? So yeah, the same concept apply. You can use this vertical bar. Vertical bar, we call this a pipe. It forwards the output of one command as an input into the next command. For example, cat file basically print the content of the file, right? Basically print the content of the file on your monitor. WC is word count. It count the words, how many words are in the input. So in this case, what does the word count do? In this case, the content of the file becomes an input to word count. So word count would count the word in the file, right? Think of it as connecting to function. I have command 1 and command 2. The pipe flow the output from command 1 into command 2 as an input. All right, so hopefully that's clear. Now let's go to another thing about permission control. Who can access the file, who can access the directory, and how to manage an environment where there's so many user on a server, right? It's kind of like manage the society, right? There's so many users who want to use the earth and its resources, so you need to manage who get permission to do what. In a computer, you can think of it as a mini world for all the user. Some user can do certain things, some other user cannot. So you can manage the user by first, there's a user type, there's a regular user with a super user. Super user, as the name suggests, anyone here try to install program on Windows and say, there's a like a ping sound and say, I need admin access to install this program. Anyone remember that when you install a new program, like a new game or something, and it's basically uh, some text that most people didn't even read, ask for admin access, whatever. Yes, I want to run and install the program. It basically makes you a super user so that you can do things that maybe it can harm your computer, but you know what you're doing, assuming. Run as an admin, run as a super user. In Unix, right? Admin is called super user. Each user also belongs to one or more group. There can be a group called, I guess in Windows, admin. In Linux, we call this sudoer. In certain distribution of Unix, it's called view. Basically, it's a user that can elevate yourself into a super user. And there can be any unlimited number of groups because there's a command to create a group. And you can assign different users to different groups. You can then use the command group followed by the username to check what group the user is in. User under the sudo group can become a super user. These are users that can install new program, for example, or change the system configuration. This is happening when you call sudo. We'll go into sudo command in a little bit. But before that, we need to talk about the ownership. Because this is a normal thing. When you create something, you should be the one who owns that item, right? The same thing goes with your computer. each file and directory has the owner. By default, if you create the file, you are the owner. But you can change ownership with the command chown. Change ownership followed by the user account that you want to change the ownership into and the file name. So you can change the ownership to someone else. Each file also has a group. The group that owns the file has its special permission. So basically, each file has 3 different permissions: read, write, execute. Read means I can read the file. Write means I can modify the file. Execute means that if the file are a program, I can run the program. All right. And each set of permission R, W, and X, there'll be one set for the owner. Owner can set its own permission just in case you don't want anyone, including myself, to modify the file. It's a read-only file. You just make sure no one has the W permission for both for our owner group and others. Group that owns the file also has its own RWX permission. And then there's everyone else in the computer, in the server, in this case, has its own RWX, right? So this allows you to set the permission for yourself, for everyone in your group, and for everyone else in the computer. And this ownership system, now let's go through some example, right? Here is a screen cap of directory structure. As you can guess, this is a really old status, right? U55, 56, this is a long time ago. But over here, you can see this part, right? The permission. So the first 3 letters is the owner. Basically, these are the owner of the file, right? So these user can read, can write, can execute whatever's in this directory. The next 3 letters apply for the group. So in this case, you see that the group is called student, right? So if you are a student group, you can read the content, but you can't write, you can't execute. And then the last 3 dash, these are others. So if you are not the owner and if you're not in the student group, you can't read, you can't write, you can't execute anything in here. All right. So this is how you can control who can access what in a computer, and you can control your own file. If you want to control someone else's file, you need superuser permission. So let's talk about superuser in a bit. Superuser is the most privileged user. I always joke that this is the god. If your computer is the world, superuser is the god that can, like God by definition, right? So by definition, God can do whatever. It can do anything. All the powerful being inside that computer. So in Linux, this user is called root. There's a user called root that can do anything inside the computer. The command su, typically su is called switch user. It change the user from one user to another. Oh, okay, that's a question. Let me go back one slide. I'm sorry. There's a question say, what does the number mean on the left of the owner? Wait, the left. Oh, yeah, actually, I forgot. Let me double check that. So let me get back to you later. Is that okay? Because I actually forgot what does the number mean. Sorry. Yeah. So great question. I'll get back to you. So in Linux, there's a super user called root. The su is a command that switch user. So su without any argument. So you type in su and hit enter. It means I'm going to switch my user into root. You would basically prompt to enter the root password. If you put in the root password, now you become root and you can do whatever in the machine. Su followed by username in that case won't change you to root, but change you to another user. It changed you to another user. But most of the time, don't use su randomly. What you want to use in many cases is the sudo command. Sudo is a command that elevates yourself. Basically, it allows you to run that command as the root. It runs that command as the root. This is exactly the same as in Windows when you hear that ping and then it asks, can I be an admin when I run this thing? It is basically run this command as an admin. In this case, run this command as a super user. And don't use the user root casually because you can actually break the machine if you don't know what you're doing. Also, don't give people root password randomly unless those people are the system admin. So here's a joke about the super user and root. This slide has been here for a long time, even before I teach this version of the class. Anyone read XKCD? It's a comic that's really geeky to the point that in many cases I didn't even read it. Anyone know about XKCD? Awesome. If you know those, awesome. You are definitely in the right place in this program. So it's a comic that a lot of time it jokes about computer related stuff. So this is one joke about sudo. So a guy asked your friend, say, hey, make me a sandwich. And your friend's like, why? Right? And then say, hey, sudo, make me a sandwich. And you comply because you become the super user and you can command whatever, right? Now we talk about the ownership. We talk about the permission. Now let's talk about one of really important command called change permission, chmod, change permission. It takes mainly two inputs, the bit mask and the file. The file can be directory, it can be a list of file. It basically allows you to change the permission of that file. First of all, you must be the owner of the file, or you have to be a super user. And the bit mask has 3 numbers, each with 0 to 7. 0 to 7. The first number apply for the owner. The second number apply for the group. The third number apply for everyone else. I'm going to show you example soon so it's more clear. And the number 0 to 7 basically means that if you want a read permission, add 4. If you want to have a write permission, add 2. If you want execute permission, add 1. So it can go up from 0, means nothing is allowed. 1 means I can execute. 2 means I can write. 3 means what? If I put a number 3, what does it mean? How can we break down the number 3? 3 is what? Exactly, write and execute. But the reason behind that is basically 3 equal 1 plus 2. It basically means that I can execute and I can write. 4 means I can read. 5 is basically 4 plus 1, means I can read and I can execute. 6 is 4 plus 2, which is actually a weird permission. I can read and I can write. Oh, actually, it's not a weird permission. I can read and I can write to it. 7 means that I can read, write, and execute. Sorry about the weird permission. The weird permission, for example, I can write, but I cannot read. Like 1 plus 2 is kind of weird, right? You can't read the file, but you can write on it and you can execute the file. Like what? Why? So some of the examples is chmod 777 test.txt means that everyone, including the owner, the group, and everyone else can read, write, and execute. Chmod 742 means that for the owner has the permission number 7. I can read, I can write, I can execute. The group has the permission number 4, means I can read to the file. And other people have this weird permission too, which means I can not read, I cannot execute, but I can write to the file, right? You typically you don't use the permission level 2. So quick question. I just said everything in a file is Linux. It's in Linux, right? That means that the program that you run, like OS, for example, is a file. Right? It is a file somewhere in your computer, right? cd, ls, rm, mk-dir. Basically, these are the command, right? And everything is a file, including the command, right? Some of them are kind of like built-in command with shell. Some of these commands are actually like the command that has an actual file. This means that, for example, ls is a file somewhere under this root directory, right? But again, when you want to run something, you need to provide the path to where the program is. So the question I have for you right now is, if I type in the command ls, how can Linux know that, yeah, go run this file called /bin/ls? It's actually where ls is. How can I tell that? How does this magic happen? Anyone want to take a guess? So when you run the command ls, it knows, okay, go run in /bin/ls. When another user run it, it knows. That's something built into the shell. Actually, it's built into the shell. This is called the path variable. And as the name suggests, anyone want to guess what does the path variable do? What should it contain? What should it contain? It actually doesn't contain all the command, but it contains the direction to the directory that might contain your command. So in this case, it can be a path to bin, like /bin, and you can add more. Basically, it's just one variable that you keep adding. It basically means that when you run a command like ls, it will search every single directory in the path variable for the ls command. So this is how it works. Your shell, right, has this variable associated with some pre-configured value. These are called environment variable, and these, each user has their own, okay, grammatic incorrectly. Each user has his or her own path variable. So you can have your own version of path variable. Your friends can have their own version of the path variable. Path is one of these variables, right? It contains multiple directories. Each directory will be separated with comma. So ls actually store in /bin/ls. So in this case, what should be in the path variable /bin, right? It basically need to contain /bin. To check where the command is, you can do which ls. Which ls is a command that would tell you, hey, ls is actually in this directory. Why is this useful? Why is this useful? Anyone? So if you used Python before, did you realize that there are people who use Python 2 and there are people who use Python 3? Because certain things are available in Python 2, version 2, and certain things are available in version number 3. Anyone realize that? That's like different version of Python. You used Python before, right? In the Python class. So one thing that you might have noticed when you install Python is it actually have multiple versions that you can install. In this case, if you install Python, I install Python 2 and Python 3 on Cisco, actually. So one thing that can happen is I call Python and I need to check what version am I using, right? So I can check with which ls. It actually tell you, okay, this is the Python command that is linked with the default command Python that I type in. So I can change it later with the path directory and combination of other commands. You can also modify the path directory using the export command. This is the command, right? And the way you specify this environment variable, you use the $. $signs means I'm gonna get the value of this. let's just say dollar sign means I want to get the value of what follow the dollar sign. So in this case, dollar sign variable name refer to the value of that variable. So you can do this. Export path equals dollar sign path colon home slash rashada slash bit. Let's break this down. Let's break this command down. What does export do? Can someone tell me what does export do based on the content of this slide? I want to change the path, right? I want to change the variable, the content of the path variable. Export path equal means that I'm going to assign whatever is to the right. I want to assign whatever is to the right of this equal sign, whatever is in here. I want to assign it to my new path variable. And in this case, I want to append, right? Because I do dollar sign path. That's the old version. That's the old version of the path. And then I append with the colon, home rashada bin. Basically, this would add slash home slash rashada slash bin to the end of the path variable. So what does it really do afterward? It would check every single thing in the path variable, including slash home slash rashada slash bin when I run the command. So here are some examples. Let's say this is the content of my path variable, right? And I run ls, The first directory that I will check, hey, is ls here? I would first check this path. If it's there, what would happen? If it's there, what would happen? Yeah, it would basically run ls inside slash user slash bin. But because we know ls is not in there, so say, hey, I cannot find ls in slash user slash bin. So I'm going to check then, is ls in here slash bin? And in this case, it is in slash bin. So it will run that ls inside the slash bin. If it's not there again, it would then check this directory. So we'll keep checking one by one until you find the command. If it's not found, it would basically print out command not found. It basically means that I check every directory. Oh, how do you check if ls is in there, right? By default, the shell program. Okay. Let's do one by one. There's a question, private chat that say, how do you check if ls is in there? Shell has a built-in features that would check that for you. If you want to actually check, you can go to slash bin and list them out. It would print out there's a file called ls that would basically run the ls command. The colon means I'm actually append as a word, as a verb, like as an actual action. I append this path and this path and this path. Basically, I'm going to keep searching one by one. This is how you can keep adding as many directory as you want to the path variable, right? So is it more clear now why we need the colon? This is so that I can separate two different paths. And so that it's not user slash bin slash bin slash user slash sbin in one single path. Now it's three different paths for the shell to find my command. Is it more clear? Awesome. Yes, exactly. Basically, this is like, I'm going to search three different locations from the first location, followed by the second location, followed by third operation. Yeah, so you can keep appending. You can have 10 different paths in there. All right. What else? So there's an echo command. Echo is like print. It print what comes next. So if I say echo hi, it would literally print hi. And you might be wondering, why do we need this? Why do we need this? The reason behind this is you can use the echo command to print our variable. So if I do echo $path, it will print out the content of the path directory. It really print the value of the variable, right? It's kind of like when you, if in Python, you do print x, it print the value of x. In this case, echo followed by $, and the variable will print the value of that variable. All right. Now let's talk about process. I actually not sure why we always end the lecture with talking about process. So it's a running instance of a program, right? It run under certain corresponding environment. The environment provided additional information required for the program to run correctly. So we will go through this in a little bit more detail. When you install a program, for example, it pull in different environment variable, not just the path variable. You can have your own variable tied to each command as well. Each process has its own unique process ID, has its own unique parent process ID, who spawned this process. Also has the user that run the command and the group number. And it has priority on, okay, is it high, low, or medium priority? So the OS know if I have 4-core CPU, I have 10 programs that are running, who gets to use the CPU? All right. Process management. This is kind of like a just not a management in the sense that you can modify the management, but this basically lists the process. You can queue the process, do the end task in Windows. Oh, what does it meant by parent process? Again, that's a great question. That's a great question. So let's say I have a program A, and inside program A, right? When you run the program, you spawn a process. But inside program A, it actually has a code that say, I'm going to run program B. Basically, this means I'm going to spawn a child process that are specific to the process that call this program. So is it more clear? Basically, when you look at the chain of processes, that's this parent-child relationship, who spawns what. And the reason we need this is so that we can trace what's the everything that we are running at the moment, and how can I manage everything that are running at the moment at any given point in time. All right. Is it more clear about what does it mean by the parent process? If I look at one process, who spawn that process? So the parent process is the process that spawn. Exactly, right? Each, like for example, when you open up YouTube, right? YouTube would spawn the video renderer, so it actually render the video, the YouTube video for you. So Chrome would spawn the renderer. It would spawn another process to interact with the driver so that you can hear the audio, right? And it gives the information that, hey, if something's wrong with this, look at the parent. It's Chrome. Chrome spawned this, so it has more information for the OS that on what could have gone wrong when something went wrong. All right. Another thing is with the parent and child relationship. Let's say I close the Chrome browser. What would happen? So in this case, this is Chrome. And this is the video, I guess, renderer. The child are killed. It will kill every single child process that process own. It tells you, okay, let's say I hit that that cross sign. I close the Chrome browser. It allows me to track are there anything that are running right now that I'm not using anymore because I closed down Chrome, right? I'm not gonna need the Chrome video renderer. I'm not gonna need Chrome MPEG for the encryption and decryption, right? I can queue all those things, right? It allows you to free up the resource because those processes use your computer resource. This is similar, yeah, if you think about it, kind of similar to class and object. It's like there's a inheritance relationship, but on the system side of things, where one thing spawn off another thing, and when you queue the parent, everything down there get queued. That sounds really, really wrong, by the way. I'm sorry about that, but yeah. Yes. Okay, we should not go that metal and like come back to okay, yeah. Again, awkward naming, but it does make sense. When you queue the parent process, the child process get queued with it, so that it free up the resource on your computer for a different program that are running, right? So the purpose is so that you can free up as much resource as possible. There's also things, since we are talking about process management, right? There's also things like zombie processes as well. These are things that are running, even though it's not actually used by anyone, and it's used up the resource. Sometimes that does happen. And also, that's also why you might want to reboot machine once in a while. When you look at process management, the command top, if you had type in top, it basically would gather a real-time data about running the processes. So one thing I would encourage you to do is basically type in top and look at, that would show you everything that's running. PS, so top is interactive. This is kind of like open up a task manager where you have to close it later, right? PS is the command that is not interactive. Basically, it would list all the running processes. Q means I'm gonna end that specified running process. This is basically similar to when I hit the word end task. Well, actually, this is basically end process. So if you go to Windows, there's a task and there's a running processes. Q will queue the processes, not the program. So if there's like a parent, that won't get queued. Job will list the current jobs that run in the background. Anything that are running in the background. Foreground would move the background process into the foreground. Foreground is, let's say you run a program. You can't If you run an interactive program, you can't do anything else unless you move that program to the background. That's when you can call more function and command. FG would move the background process back to the foreground. Control C would pause the current foreground process and move it back to the background. So here are the example of using PS command, right? PSAUX, A means I'm going to show process for all the user. U means I'm going to show the process owner. And X would also show processes that are not attached to a terminal, right? Why is that useful? Processes that are not attached to a terminal. Basically, it means that it's some of the process, for example, system process that is shown here, right? That allow you to see, hey, anything else that someone is running, like root are running, or system is running, network are running. These are system level processes that gets spawned, and kind of most of the time these things would kind of manage your machine. It would show you things that are not launched by anyone, right? Anyone, because it's not attached to anyone's terminal. Some example of the queue command. Queue basically will send a single sig queue. The way the computer works is it's kind of like a command based. It's a signal based thing. Sig queue means I'm gonna send a command called sig queue to that process. When the process receives the command, it would commit suicide. Yeah, it would queue itself. So if you do queue 1, 2, 3, 4, 5, this will queue the process with the process ID 1, 2, 3, 4, 5. And this can be useful. For example, you have a program that runs infinitely, right? It's a buggy program. And it's been using the resource and you know it's wrong. You need to kill it. So you can send the kill command to that particular program. It also can be used to queue zombie processes. These are processes that are not like attached to anything and it's basically are running, but it's not using or doing anything useful. So you can queue the zombie processes that way. Some other useful command, wget download the file from the internet. You can zip and unzip for compress and decompress. Tar can also be used for compression, decompression as well. Co is a HTTP client. So we'll talk about this a little bit more in our lab 1. Head would display the first n line. Tail would display the last n lines. Again, we'll use this in lab 1. Some other useful trick when you go to the command, you can use the up and down arrow to cycle through the command you type in earlier. So if you go down, 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 or up, 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 it will cycle through all the previous or the next command you have put in. It's kind of like a history of your own command that you use for your computer. The tab will auto-complete the file or folder name if it's possible. Control C would stop the current program. Control R would allow you to search command history. Control L would clear your screen. Or you can type in clear, I think. And you can also dealing with multiple names. Actually, let me stop here for the time being, and we'll resume the lecture in on Tuesday, next Tuesday. All right, let me mark here. Stop here. Yes, a lot of stuff. And here, so that I know where I stop, because we want to move to in-class exercise 2. It should be fun. This is again, it's a group activity. So what I did before the beginning, yeah, sorry. Actually, my recommendation, if you need something from this lecture, go through just the PDF first, because today is about like, okay, these are all the commands you can use. So go through the PDF first so that you know if you can just be done with that, because it's just a lot of new information, but it's just a description of the command, right? Yeah. Anyway, so in class 2, we are dealing with permissions and some basic command, like how do you get the content of the file. So right now, what I have in the Cisco machine is there are 4 hidden messages inside some of your friends' home directory, whatever that means. We talk about that today. There's also 1 home directory. So basically there are 5 spatial directory right now. 5 spatial account. 4 of them have the hidden messages. One of them is the place where you should put all the hidden messages together. The thing is, if you are that lucky person that has the home directory with the hidden messages, you can check by logging into your home. They're basically logging into Cisco. You can see if anything is there or not. If nothing is there, you're not in this category. If you see a directory, I think it's called hi. You go in that directory. In there, there can be 2 things that happen. You can have the hidden message, or you can be that one guy that had this put all the hidden message here, right? So if you have the hidden message, you're lucky, you don't have to do anything. You don't have to do anything. But your only task is don't tell your friends what are the messages, because if by the end of today, by midnight, no one can crack all the messages, you get extra credit. So your reward is make sure no one know the messages. So don't tell your friends that. If you have the home directory that contain the file where your friend's supposed to put in all the hidden messages together, make sure you do something with the file so that everyone can modify. So if your friend found the hidden messages, no, you don't have to do it in class. It's by today midnight. By today midnight. Okay, you have to go to the hospital. How about I change the deadline to tomorrow midnight? Is that okay? You have until tomorrow midnight. The only unfair is to the four students with the hidden messages. because I give you guys more time. So let's keep this activity until tomorrow midnight. All right. We will clarify that a little bit. We will clarify that a little bit. So hopefully it's not confusing anymore. You need to figure it out. How do you check other home directory? I mean, ls command might be handy, right? And you know where the home directory are, right? So you can, but there's tons of those. So there's also things that you can do to check, hey, maybe I can get some more information from the information I got after I type in ls or something like that. I think that's too much hint for everyone, because you are basically ganging up on your 4 friends that has the hidden messages. All right. So if you have the directory that has the file that say put that inside the file say put the hidden messages here, you make sure that your friends can modify the file and then go help your friends. There are 4. So if you don't have anything on your home directory, work together in groups of the entire class versus the 4 with the hidden messages to find all the 4 hidden messages. All right. And you put them together. If you're in this group, you get extra credit if you found all the messages. So the rest of the class get extra credit if you can put together the 4 hidden messages. If you cannot by tomorrow midnight, you got the full credit for the in class for trying, but you don't get extra credit. The person who will get extra credit are those 4 with the hidden messages. So yeah, as I said, if you have the hidden messages on your directory right now, you're lucky, you get full credit for the in class by default. But you just wait until if everyone can crack the messages. And also you can't just say the message out loud. Go and modify this. And please feel free to use Discord to work together on this. So any questions? Because I feel like my explanation is not as great. In your submission, yeah, let's the wish hunt begin. Well, I guess a hidden message hunt. Submit just your user ID on Canvas. There's a way you can figure it out. Okay. Hi is a directory, and inside that directory, there's a text file. So if you log in and you found those, yep, you have the hidden messages. So don't tell your friends what are in there. How do I even tell which student is in Cisco? There are commands for that, so I'm not going to tell you how. We will basically, I will tell you what would I do on Tuesday, because Tuesday is after the deadline. What if the user doesn't allow us to read the file? So if you have the hidden messages, please do nothing, because now your friend can actually check the content of the file. There should be only 4 hi, yes. When you plan to upload this lecture, by the end of tomorrow, I will upload both lecture 1 and 2. Wait, then you can, well, I'll try to get it done by the end of today, so you have some content to work on the in-class exercise. Wow, you're quick. There are 5 high, because one of them would be where you put out the hidden message. Are you almost done? It's just weird. Okay, one of your friends is almost done trying to work for everyone else in the class because he found all of them. Okay, cool. So, wait. I just checked. Let me double check that. If it's permission denied by the end of 4 o'clock today, it should be visible if you do something. Let me double check. Give me a few. This is too quick. This this is too quick. This is too easy for some of you. I'm sure because you used Linux before, right? Is it? Yeah, if that, well, now that's like three of you guys that got everything done. So yeah, you guys are done. Just submit your user ID. But you might have realized, right, that this seems like a task that some of you might be asking, like, how can I figure out what are the different users in the class, or how do I do? Try this out on your own, at least for like 15 or 20 minutes, because as you might have realized, if you know what to do, it can be really quick. The, this is how you can kind of manage the system using different commands. And you can now clearly see the benefit of it, right? I have a certain task for you, and if you know what to run, you can get that quickly. So let me first double check. What day is today? Today, 28, 28, 28, 28. Okay, yeah. Yeah, you can, I can from my account read the content. So can someone tell me if you can read the content of the file using certain command? Do you tell, so if you got it already, just keep it to yourself, because right now how about I just let everyone win, all right? It's not fair for your friend with the hidden message. Everyone get extra credit. It's too quick. Yeah, for that student that sent me the private messages, that's how I plan. So you should use that. So yeah, everyone got extra credit. This is way quicker than I think, which is great, right? But if you haven't tried this out, this you haven't this if you haven't, so submit your user ID, all right? Submit your user ID in class too. Everyone got yeah, you try it out, guys. We have 15 minutes and you realize how quick this can be done. How quick can this be done? With some loophole that I left there, and you should be able to kind of figure out with the command we learned today. And also be aware, right? Also that you can visit the file on your friend's directory if you don't you're not careful with it. All right. This is another lesson learned. Anyone heard about the capture the flag competition? Yeah, if you have to leave now, it's fine. Thank you. This is too quick. Anyone heard about the capture the flag competition? Yeah, see you next week for the student that have to leave. So if you haven't heard about it, this is like a security competition, right? Yeah, so if you know capture the flag, not in computer science related, that's another fun thing to do. It's like activity. But uh, in computer science related, it's like a hacker competition where you have multiple tasks where you have to defend also as attacking someone else. And if you're curious about that, you can kind of Google capture the flag hacking and things like that. You see that, okay, oh, I mean, there are competition in that direction as well, where if you know through and through about like Unix and the computer systems, you can be a part of this group of I would say white hat, right? The hacker that do good things and try to like look at different loopholes that you should close when you have a fault program, like security leaks and things like that. Um, oh, someone changed the permission. Okay, cool. Yeah, one of the high folder where you should put the message into is not accessible because I didn't have the right permission. I guess now it's the critical bottleneck where that guy have to give you the right permission. But I guess you know now you know the point of the task, so I'll give everyone extra credit, right? So yeah, just make sure you submit your user ID on the submission site.